Hey everyone, and welcome back to our channel where we post daily videos on cutting edge technologies. Picture this, a pre-trained model on 1.3 trillion tokens from diverse textual and code dataset. This isn't just your average model, it is a coding powerhouse. Yes, we are talking about the StableCode 3B model. It is a colossal 2.7 billion parameter decoder only language model that is here to revolutionize the way we approach code completion. And guess what? It speaks the language of 18 programming languages carefully chosen based on the insights from the 2023 Stack Overflow Developer Survey. The StableCode 3B model takes the code completion to another level. So let's see how you can actually perform code completion and code generation using the StableCode 3B. For this video, I'm going to be using the Google Colab and I'll run all the commands right here in my notebook. So in order to access StableCode 3B, you can always go to the Hugging Face and here you have all the information about the model. If you scroll down a little bit, you will have the code that will help you in getting started with generating the text with the StableCode 3B model. So this is the code which I'm going to use. For that, we need torch and we need transformers. So I'm gonna head back to my Google Colab and firstly I'm gonna import the torch. So I'm gonna say pip install torch, run it, and you will see that all the required libraries associated with it will be downloaded. Then I need to install the transformers, but since the StableCode 3B model is present in the Hugging Face, so we need to use the transformers package from the Hugging Face as well. So instead of simply typing pip install transformers, I'm gonna say pip install and then provide the path for the GitHub where the Hugging Face transformers is present. Run the cell and the transformers from the Hugging Face will be installed in your notebook. Alright, so the transformer is successfully imported. Now we need to add the code which was present inside the Hugging Face page for the StableCode 3B model. So this is the code for getting the response from the StableCode 3B model, and I'm gonna use it inside the notebook. So here let's paste the code. Firstly, you have to import the necessary libraries. So I've imported the torch, and from the transformers package I've imported the auto model for CodeLLaMA for creating the model and the auto tokenizer for generating the tokens using this StableCode 3B model. Then the next thing is to load the tokenizer from the Hugging Face Stability.AI with the Trust Remote Code enabled. So here I am initializing the tokenizer by using autotokenizer.from pre-trained because this model is a pre-trained model and I am providing it the path where it is present, and I am also setting the Trust Remote Code to be true. After that, we have to initialize the model. So I'm gonna initialize the model using the auto model for CodeLLaMA.from pre-trained because this model is pre-trained, inside which you have to pass 3 parameters. First is gonna be the path of the model, which is the StableCode 3B present inside the Stability.AI in the Hugging Face. Then for the model, we are again setting the Trust Remote Code to be true, and for the torch_d type, I'm setting it to be auto. And this is being done to allow the automatic d type selection. After that, we have model.queueDup. This is done in order to move the model to the GPU if it is available. So I'm going to remove this line because GPUs are not available inside the Google Colab. After that, I am using the tokenizer, inside which firstly you have to pass the prompt for which you want to generate the code, and then we are setting the return tensors equal to PT. Here, firstly, this tokenizer part uses the tokenizer object to tokenize the input text which is present inside this double quotes, and then we have the return tensors equal to PT. This argument specifies that the output should be a PyTorch tensors. Then we are using .toModel.device, and this is used to move the resulting PyTorch tensors to the device. So once you have tokenized the input text which is present inside these double quotes, now we are gonna use the model to generate the tokens for the response. For that, I'm gonna use model.generate function, inside which you have to pass the input tokens as pointer, Then you have to set the max new tokens value. It can be any value. I'm going to set it to 100. Then we have the temperature, which is the value of the creativity or the uniqueness. I'm going to increase it to 0.7. And then we are setting sampling to be true. So this code was by default written inside the Hugging phase. I'm going to change it to provide it a new prompt. I'm going to say create a Python program that takes a number as input from the user and prints a Fibonacci series up till that value. Okay, and I am passing this input tokens to the model.generate function where I have set the max new tokens to be 100, temperature 0.7, and after the new tokens using the models have been generated, then I'm simply gonna print these tokens. But firstly, I'm gonna decode the tokens and I'm setting the skip special tokens to be true because there may be some special tokens which might not be part of our response. So once the tokens for the response are generated, you first need to decode it and then I'm simply printing it. Now let's go ahead and run the code and you will see that it will start downloading the required packages and will take some time in order to run the code. You need to remember that if you are running the code for the first time, then it will take a lot of time in order to download the TensorFlow and Torch as well. But for the remaining runs, it will not take that much time. Alright, so the response is generated and it has provided me the code that takes a number as input from the user and then pass that number to the Fibonacci function in which the loop runs up till that value which the user has added. So now let's go ahead and test if this code is correct or not. So let's copy it and I'm gonna move to the VS Code and I will paste the code here. Let's quickly run this. It will ask you to enter a number. I'm gonna say 5 and then it is printing the Fibonacci series up to 5 digits. So this means that it has generated the correct code for us. And in this way, you can generate code for any language that you want by simply providing your prompt right here inside the double quotes. So let's test it with another example. This time I'm gonna say create a login page using Tkinter that has a label and a text field for username and password and a login button to log in, and it should take us to a new page called home. So once you have provided it the prompt, now you simply have to go ahead and run this cell again and then wait for some time until it generates a response for you. Alright, so the response is generated but it is incomplete, maybe because of the max new tokens. So I'm gonna change it to 800 and let's go ahead and run this cell again and wait for it to generate the response for us. Alright, the response is generated and in the start it has added the required libraries, then it has created a function for creating the login page and then it have another function for creating the home page in which it has set all the configurations. Then there is the configuration for setting the page title and the text fields, buttons, etc. So this is the entire code for a Tkinter application that has a label in the text field and actually performs the login functionality. So in this way, you can generate code for any application in any of the programming language that you want. So now using this tool, we can also create an application that have a user interface in which it will ask the user to enter the prompt inside a text field and then the generated code will be displayed inside another text area on the user interface. So let's see how you can do it. Firstly, I'm gonna remove all of this code right here. It will go inside a function. Then firstly, I'm gonna install the Streamlit because the application is gonna be a Streamlit app. So I'm gonna say pip install Streamlit, run it, and once the Streamlit is successfully installed, now I'm gonna add a new cell right here in which I will write the code for my Streamlit app. So here is the code for the Streamlit application. Inside the main function, we are firstly setting the title to be code generation app. Then we have a text input for entering the prompt for the code generation, and whichever value user will enter will be stored inside the variable called prompt. After that, we have a button saying generate code, and if the button is clicked, then we are calling the generate response button in which we are passing the prompt. And the response is saved inside this variable which is then being displayed using Streamlit. So the generate response button is right here, and inside this function body, we have to pass the code which we have previously written in order to get the response from the StableCode 3B model. So here is the code for it. Let's scroll a bit. It is showing error here because we have not imported the torch and transformer. So let's do it. Then you will see that the error will be resolved once we set the indentation. So after setting the indentation, this is how your code looks like. Firstly, we have the generate response function, which is actually being called once the user enters the prompt inside the text input and the generate code button is clicked. So now let's go ahead and run this to see our application. So in order to run the Streamlit app, you have to follow a few steps. So for the first step, you have to type this command and run it, and this will provide you the IP address or in the version v4. So you have to copy this, then create a new cell. But before that, you have to save it inside a file. You have to type the command from google.collab import drive. This is actually being done in order to mount the drive to the Google Colab. And once you will run this, it will ask you for permission to connect to the Google Drive. So you can select the Gmail account whose Google Drive you want to provide it access to. Then once your drive is mounted, next thing is to store this file inside your drive. Then you have to go to the above cell and copy all of the code of your application. So I'm going to copy this code and I'm going to create a new code cell inside which firstly you have to write $% write file, and then you have to provide the file name. So I'm going to call it app.py. Once you do that, move to the next line, paste all of your code right here and run it. And it will write your code inside a file called app.py. So if you click this icon, you will see that you have the file app.py inside which you have all the code for your application. And then the last step is to run the Streamlit application. For that, you have to type the command streamlit run app.py and npx local tunnel -- port, which is 8501, and run it. And once you do that, it will provide you a URL. Click on the URL. It will redirect you to a page that looks something like this. Here you have to provide the tunnel password, which is actually the IPv4 which you have just copied previously. So paste the IP address right here, click on the submit button, and it will redirect you to your Streamlit application. Alright, so this is how our application looks like. Here is the title. Then we have a label saying enter a prompt for the code generation, and this is the text box for our prompt. So I'm gonna prompt it, create a C++ program that takes a number as input from the user and calculates its factorial. Once you are happy with the prompt, go ahead and click on the generate code button, and it will take some time in order to generate the response for you. So here is the result. You can see that it has provided me the code in which it takes the input from the user, then pass it to calculate the factorial of the number. And in this way, you can use the StableCode 3B model provided by the Hugging Face Stability.AI in order to perform code completion and code generation. That's all for this video. Thanks for watching.